So in this video, we're going to learn our third method for solving systems of equations. Solving systems by using elimination. This is my favorite method to use. This is kind of my go-to. So my objectives is to identify situations to solve systems by elimination, and then you can solve the system actually by elimination. So what do you need? For us to use elimination, we need the like terms to line up. So notice in the example, the 3x and the 7x, these are like terms, they line up. So do our y's, and then our numbers also line up. This is a non-example. It looks like the x's line up, but the y's are not on the same side of the equal sign. So these do not line up. Then the numbers do line up because they are on the right side of the equal sign. So for me to solve this by elimination, I would have to move one of the y's, either the 9y to the right side or the negative 4y to the left side. So once we have them lined up, we need to make one of the pair of the variables opposite, one pair of the like terms. So for example, 3x and negative 3x are opposite because they add up to 0 or 0x. To do this, if they are not opposite, we are going to be able to make them opposite by using multiplication and equivalent expressions. So we're going to be able to multiply one or both equations by a number, and that will give us the variables to be opposite. So here's an example of solving by elimination. Again, notice they line up. I have the x's together, I have the y's together, the equal sign, and then I have the numbers, the constants together. And then also, notice I have variables opposite. The 5x and 3x are not opposite of each other. But the negative 6x and negative 6y and 6y are opposite of each other. If I add these two together, that would make 0. So I can go right away into elimination. So elimination, once you have one pair of variables opposite, you add the two equations. You add the like terms. So 5x plus 3x gives me 8x. These make 0, so we don't need them anymore. And then I have negative 32 and 48, which gives me a positive 16. So I divide by 8. My x-coordinate is 2. So elimination is pretty slick, but we only have done half of it because we only have the x-coordinate, so we need to get the y-coordinate. So I can plug into one of the two equations. It doesn't matter which one. I'm going to plug into the bottom one. It just looks easier to me. Plus 6y equals 48. I just replace x by 2 because I know what x is. So I have 2 plus 6y equals 48 minus 6. 6y equals 42. Divide by 6. Y comes out to be 7. So the point of intersection of these two lines is 2, 7. So in B, again, notice we have our first criteria that the variables line up. We have the A's and the B's, the equal sign, and the numbers. And then we have to look to see if we have a variable opposite. We have an A and a negative A. Those are opposite of each other, 1 and negative 1. The B's are not, and the numbers we don't worry about right now. So I can just go ahead and add these two equations. So A plus negative A, that's 0. So we don't need to worry about that. Negative B plus negative 2B, that's negative 3B. And then 8 plus 5, negative 5 is 3. Divide by negative 3. B is negative 1. So then I'm going to plug negative 1 into B into one of these two equations. I'm going to pick the top one. So I have A minus negative 1 plus 8. That's a positive 1 since I have two negatives in a row. So I have A equals 7. So you might be thinking to yourself, okay, so how do I write my point of intersection because I don't have an x and y? Well, we always write them alphabetical. So since A is first in the alphabet, we go 7, and then B is next with negative 1. So my point of intersection of these two lines is 7, negative 1. So C is our first example when we have the variables lined up, m's, t's, equals, and the numbers, but we don't have a variable opposite. So this is where we're going to use multiplication to get one pair of variables opposite. And you can pick. You either can do m's or you can do the t's. I'm going to get rid of the t's. So I notice on this one I have a positive t. So the opposite of positive t is a negative t or a negative 1t. So to make this t -1, I need to think to myself, what should I multiply this equation by to get a -1t? Well, the answer is -1. So I have -m minus t equals -6. Now my variables are opposite. I rewrote that one and made something equivalent to it. So I have 4m, the t's cancel out, equals 8. Divide by 4, my m is 2. So now I can plug in, and again, I have 3 options to plug in. I can do the first one, I can do the second one, or I can do the new one I created. It doesn't matter. These two, the first one and the third one, are equivalent expressions. But I'm going to do the first one because it looks easier. So I have 2 plus t equals 6. You probably can do this one in your head, but just minus 2. T equals 4. So again, alphabetical. M is before T in the alphabet, so my answer is 2, 4. Alright, so D is another example where the variables line up, but they're not opposite from each other. So you need to pick which variable to get rid of. It doesn't matter. I'm going to get rid of the x's in this case. So what I need to do is think to myself how to make 8x and 3x opposite of each other. So really you're looking for the least common or the lowest common multiple, the least common multiple of 8 and 3, which is 24. So I'm going to take this top equation times 3 to get 24 plus 15y. Don't forget to multiply the 6. A lot of students forget to do that. And then on the bottom one, I need this to be a -24, so I need to multiply this by a -8. So I have -24, I forgot my x in the first equation, and in the second one, plus 16y equals -80. Now I can add these two, so I get 31y. That gives me a -62. Divide by 31. Y gives me -2, or y equals -2. So then I can plug in. I actually have 4 equations to plug in since these two are equivalent to the bottom two. I'm going to do the second one. Looks a little easier to me. -2, -2 equals 10. So 3x plus 4, 2 negatives make a positive, 10 minus 4, 3x equals 6, divide by 3, x equals 2. So my final answer, alphabetical, 2, -2. So on E, notice the two are lined up. They're not as normal. We have y's and x's and then the numbers. So to do this by elimination, I just need one to be opposite. I can pick any one. I'm just going to get rid of the x's. So I'm going to multiply. This is -2, and I can make this a +2 by multiplying by 2. So I have 2y equals 2x plus 12. So I have 3y equals, it's like 9. Divide by 3. Y equals 3. Can substitute back into the first one. So I have 3 equals x plus 6 minus 6. That gives me -3. So my final answer is -3, 3. Alright, so in these two, again, I don't have them, I have them lined up, but I don't have them opposite. I have a 2x and I need a 4x, so I can make this a -4x by multiplying the top one by -2. So I have -4x plus 6y equals -18. Well, notice the 4x's make 0. The y's are opposite, so I get 0 equals -13. If you remember from the last video in equations, this means no solution. These two lines are parallel to each other. So on G, I need them opposite. If I want to make the 4 a -12, I need to multiply this equation by -3. Again, make sure you multiply everything. Don't forget the number after the equal sign. That's -36. Well, notice everything is opposite of each other. So So I get 0 over here, and I get 0 over here. So that means these two lines are the same, and so it's many solutions. So just to review, for us to solve by elimination, we first need the equations to line up with the like terms. We need to make one pair of the like terms using opposite using multiplication. So we have to make awesome like 3 and -3. And then we add the two equations together and solve for the remaining variable. All right, so this includes your third method of solving systems. You are done learning all your methods. Just a reminder to do your reflections so you get credit for watching this video.